All right, so what are similar figures? Well, they are just figures that have the same shape, but not necessarily the same size. Okay. Also, when you see similar, you might see this little symbol, which means similar. Okay, so if you see two figures that are the same shape but not necessarily the same size, you might see this little guy in here. I think he's called a tilde, if I remember correctly. He means similar. So these figures right here are similar. Why? Because they are the same in the shape, okay, but they're not necessarily the same size, right? So we can see these are both trapezoids. This has a straight side, this has a straight side, this one's angled, this one's angled, okay? But also, these are similar figures. Right there. Pretty funny. Anyway, so why are they similar? Well, they're similar because they are the same shape. You know, we're going to say relatively, I'm sure. They're slightly different, but pretty much they're obviously we're all born at the same time. But they are also the same size. So remember, the key word here is necessarily. They can have the same shape and the same size, or they might just have the same shape but not the same size, and they're still similar, right? So these two are similar. These three are also similar. So when we're talking about corresponding similar figures, though, we need to understand what corresponding parts are. Okay, so what are corresponding parts? Well, they're sides or angles of similar figures that have the same relative position. So let's go back up here, right? I'll bring him down. All right, so what are the corresponding parts here? Well, I would go down here and say, you know what? AD and EH are corresponding. Why? They have the same relative position. All right, I would say that GF and BC are also corresponding parts. Why? They have the same relative position. Now you might get in a situation though where you see something like this. All right, so what are the corresponding parts here? Well, you know, I think you probably understand, but the longest side in here is going to be corresponding to the longest side on that one, right? If they're similar figures. And, you know, the shorter side here is going to correspond to that shorter side there, and of course this side here would correspond to that side there. Okay, similarly, this angle would correspond to that angle. This angle would correspond to that angle. And this angle right here would correspond to that angle right there. All right, so let's talk a little more about the properties of similar figures. So I've drawn two similar figures here. Okay, and the way that I would actually say, hey, these two figures are similar, I would actually write it like this. I would say triangle, so a little triangle, and I would name this triangle, and the triangle is going to be named by its corners. So we have A, B, and C. So I'd say triangle A, B, C. We said they're similar, so how do we write similar? Remember, it's the little tilde, that guy. It's similar to, well, what's the name of this triangle? D, E, F. We go in alphabetical order, okay? Triangle, D, E, F. All right, so that's how you would write that they are similar. Now, we're going to talk about corresponding angles. Now, we know that these sides are corresponding because they're similar figures, right? So this side corresponds to that side, this side corresponds to that side, this side corresponds to that side, so on and so forth. And I forgot I need to draw little right angles. They are right triangles. But the sides aren't the same. But what about the angles, though? Here's the thing. You know, this side is 4 and this side is 8. But check this out. What types of angles do we have right there? Well, they're both what? Well, they're both right angles, right? So how do we write that? How do we say that? Well, we actually use the word congruent. Okay. And what does congruent mean? What do you think? Well, in layman's terms, it means exactly the same. Okay, congruent means exactly the same. So if I were to talk about these two angles right there, well, let's see. This first one is angle C, and that one's angle F. So if I were to state that those things are congruent, I would say angle C is congruent, and when I write congruent, I use the similar, but then I put an equal sign under it, okay? So it's congruent to, which angle? This one right there, angle F. All right, so what other angles are congruent? Why don't you take a minute, fill the rest in here of the congruent angles and then play the video when you're done. All right, awesome. I'm sure that you had this right there. Okay, so angle A is congruent to angle D, right? Why? Because we're talking about similar figures, and these are the corresponding angles. And angle B is congruent to angle E. There you go. So we got to remember that because they're similar figures, all these angles like C and F here are not only corresponding, they are also congruent. But is side AC congruent to side DF? No. How do we know that? Well, it says that's 4 and that's 8. So remember, congruent means exactly the same. So the sides are not congruent. They are only corresponding, but the angles are both corresponding and congruent, or exactly the same. Now there's some other really cool stuff about similar figures, okay, and we're going to use these two again as our example. It has to do with the ratio of the lengths of corresponding sides. Okay, so I'm going to pick a side right here, AB, right? The ratio of AB to its let's see, well, we'll do AB over its corresponding side. So AB would correspond to DE. Is actually going to be equal to, pick another side from this figure that you got AB from, let's do BC, over, well, who does BC correspond to over here? EF. There you go. All right, so when you put corresponding sides equal, or corresponding sides of similar figures equal other corresponding sides, okay, of similar figures. And I'll prove it to you. AB is 5, right? Okay. Over DE we said was 10. And I'm claiming that that equals, well, let's see, BC was 3 over EF, which is 6. Well, let's see, if I simplify this down, last time I checked, 5/10 is a half, and that equals, well, 3/6 is also a half, okay? And so if we were given this problem here, or they gave us these two figures and said, find the ratio of the lengths of corresponding sides, our answer would be 1/2. Or you could, or circle this one. It doesn't really matter. It's not really either one of those. It's just the fact that the ratio of corresponding sides is 1/2. Okay. So let's talk a little bit more about congruency. Okay. So two figures are congruent if they have the same shape and size. So same shape and the same size. Okay. So if we go back up to our kind of right in the beginning, right, these two figures that we talked about here, right, were they congruent? No. Were they corresponding, though? Or similar, I'm sorry, were they similar figures? Yes, they are similar figures. Now how about these guys, though? Are they similar figures? Yeah, they have the same shape and they have the same size, okay, which is interesting because when they have the same shape and the same size, they're also congruent. So these guys here are both, what do I keep writing corresponding? Similar and congruent. But actually that's kind of redundant because if you say something is congruent, it also has to be similar. So, you know, you could just say they're congruent. But just so you know, definitionally, they fit both. All right, so I've given us this, and I want you to tell me what this means. Okay, what does that mean? We're going to call this thing item number 5 here, sorry. Triangle JKL, that sign, triangle PQR. What does this thing mean? Well, remember, it means congruent. This just means similar by itself, and this means congruent. Okay, so it's a similar sign with an equal sign under it. So, in congruent figures, we said that the angles are all the same, right? Or the corresponding angles are the same, I'm sorry. So if I want to figure out, okay, let's see, what angle corresponds to J? Well, you know, in this one it's pretty evident, but sometimes it's not as easy to see. So what I like to do is I like to go to the name of the triangle, okay? Angle J. Well, I know the angle he's going to correspond to is going to be, since he's the first letter of this triangle's name, it's going to be the first letter of this triangle's name. So it's going to be P. So I would say angle J and angle P are the same. Okay, and that's what that means, that little kind of, semicircle in there. All right, so then, well, what about angle L? Well, L is the last letter in this name, so he's going to correspond to angle R. And since we've already drawn two angles, each with one little semicircle, I'm going to draw angle L with 2. But we said angle L corresponds to angle R, so I'm going to give him 2 as well. And then lastly, angle K, well, he's going to correspond to, well, he's the middle letter here, so he's going to correspond to Q, which is the middle letter there. So angle K, and I've already done angles with 1 and 2, so I'm going to do 1, 2, 3, and then 1, 2, 3. All right? But that's not the only thing that happens in congruent figures. Remember, congruent figures have the same shape and size, right? So let's take this side here, side JK, right? So side JK is congruent to what side? Well, JK are the first two letters, so the first two letters here are PQ, which tells me JK is going to be congruent to PQ. So I did one little dash there, I'm going to do one little dash there, okay? And that dash is really big, I'm sorry. Now, what about this side here? Okay, JL, going in alphabetical order. Well, it's the first and third. So the first and third here are what it's going to correspond to and be congruent to. So angle JL, I'm going to do 2 dashes there. It's congruent to PR, 2 dashes there. And then lastly, the longest side of these triangles here, angle KL. KL is the second 2 there. The second 2 there is QR. So these are going to be congruent also. All right, so there you go. That is all about congruency. And if we were to write these things out, that they were congruent, I would say this. All right, so we talked a little bit about angles of writing how they're congruent, right? Angle J is congruent to angle P. But with the sides, we didn't get to it too much yet, so I just want to make sure we're good with that. This is how you write two sides being congruent. Okay, we said JK is congruent to PQ. Okay, so that's that side right there and that side right there. And this is how you write it. That right there means the side JK. Okay, side JK is congruent to side PQ, and you can read the rest of them through there. All right, so I just want to hit one more time, and this will be the last thing, about the importance of the names, okay, of the names of shapes and figures. So here they've given us, well, see, A, B, C, D, something, W, X, Y, Z. What does that something mean? Again, that means congruent, right? And let's say they say find side WZ. So that right there. We don't know what that is, but we do know that, hey, if these things are congruent, that means that this WZ here is going to be equal to one of these sides over here. But the question is, which one? So, let's see, WZ. That is the first and fourth letters of the name of that trapezoid, right? So what are the first and fourth letters over here? Well, that would be AD, right? So AD, let's look up here to AD, and lo and behold, AD is 12, right? It's 12 meters. So what is WZ? Well, side WZ equals 12 meters. Now, the reason I say it's important to, understand the names and be able to say, the first and the third, the first and the fourth, the third, the second and the fourth, blah, 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 is that sometimes the figures can be just kind of hard for our brains to figure out, this side, this WX, is actually the same as this side, this AB, right? And sometimes I don't draw the figures as well as I could. So it's really important to look at the names because the names won't fail you. All right? So that is all I have for you guys. You're awesome for sticking with it. I look forward to seeing you later in class talking more about similar, right, and congruent figures.